Problem number 3 here is going to be very similar to problem number 2. We're just going to add in one slight more baby step to go just slightly beyond the empirical formula as compared to the molecular formula. So you'll notice that the setup for this is identical, except they have given us this whole thing about later it was discovered that it weighs 224. We're going to ignore that for now. So for right now, let's just ignore this information because it says later it was discovered. Yeah, I'm going to ignore that for right now. So what we're going to do is we are going to try to get the empirical formula just like we did before. So I got a 532 gram sample and I got 1254 grams of carbon dioxide and 342 grams of water. Let's go ahead and start the process just like we did before. So I'm going to start with 12.54 grams of carbon dioxide. I'm going to multiply that by 1 mole of carbon dioxide for every 44 grams. And then I'm going to multiply that by 1 mole of carbon for every 1 mole of carbon dioxide. So I'm going to get 1254 divided by 44 is going to get me 285. So 0.285 moles of carbon is my first step in the process. So that number there, I'm going to go ahead and put down here this time as C, X, H, Y, O, and Z. I'm going to go ahead and put that in for my X, and that's going to be 0.285. So that's 0.285 that's there. Okay. Going to go ahead and do the same thing with the water. So I have 3.42 grams of the water times 1 mole per 18 grams. That's 8. Sorry, my handwriting is bad to begin with, and then you add it on with a stylus, and it makes it boss level difficulty. So that's 2 moles of hydrogen for every 1 mole of water. So that's 342 divided by 18 twice. And then that's going to be 0.38. So that's 0.38 moles of hydrogen. That is there. Shrink that guy down a little bit so I can come down here. And that's 0.38 moles there. Like so. Now I can't get the oxygen until I figure out how much carbon and hydrogen were there so that I can subtract it from the total. So the total was the 532 that was here. So I've got 5.32 grams of C, H, and O. I'm going to subtract out the grams of the carbon, I'm going to subtract out the grams of the hydrogen, and that's going to leave me with the grams of the oxygen. I just need to know how much carbon and hydrogen I have. Well, the hydrogen's easy because it weighs 1. So that's 1 gram of hydrogen for every 1 mole of hydrogen. So that then is going to be 0.38 grams, I should say, of hydrogen. So I'm going to come down here and I'm going to subtract out the 0.38. Carbon weighs a little bit more. Carbon weighs 12 grams per mole. So that's going to be your 285 times 12. That's 342 grams of carbon, like so. So I'm going to come down here, I'm going to subtractify out 342 grams of the carbon, so 532 minus the 342 minus the 0.38 gets me 1.52 grams of the oxygen, and I can't put that down here yet until I turn it into moles. So one more step here. 1 mole of oxygen per the 16 grams of oxygen. So that's going to be 152 divided by 16. So that's going to be 0.095 moles of oxygen. So I can now come down here and I could call that 0.095. So now what I want to do is I want to divide these by the smallest of the 3 numbers, which is the 0.095. Divided by 0.095 divided by 0.095. So that's going to get me 0.285 divided by 0.095 gets me 3. So that's going to be carbon 3. 0.38 divided by 0.095 is 4. So that's H4. And then O, 1, but you don't have to put the 1 there. And remember, that is the empirical. That's the empirical formula. So my empirical formula is 3, 4, and 1. That's there. Now, how does that going to help us answer what the question is actually asking here? All right, let me separate this out. I don't want this over there. Well, remember, the empirical is just the lowest whole number ratio. It could be any multiple of these numbers. So 3, 4, and 1 is the lowest, but it could be 6, 8, and 2. It could be 9, 12, and 3. And again, it could be 300, 400, and 100 for all we know, right? It could be any multiple in there. Well, how are we supposed to know which multiple it is? We're going to need to know more information. So that's, remember that thing that we erased earlier? Well, that's what this is trying to tell us. This says that later it was discovered that the actual mass actually weighs 224. So then the question becomes, which of these multiples actually weighs 224? Well, I don't know, neither do you, until we do a little investigating of it. The easiest way to do this is to start with the empirical. 3 carbons is 36, 4 hydrogens is 4, and then an oxygen is 16. This stuff weighs 56. Now, you can go through, if you want, and do each of these in turn. You can say, well, if that's 56, then this is the second step. Then that would have to be 56 twice. That would be 112. And then the next one would be 56 3 times. So that would be 168. And if I kept going, it would be C12, H16, O4. So let's see, 56 times 4 is 224. Oh, there it is. That's our guy. So that's kind of the long way about doing it, is that you can start with the first one and just work your way up until you hit it, right? Usually it doesn't take that long. But if you want to go straight to the source, then the easier way to do it is to take what they gave you, which is the actual, which was 224, divide it by the empirical, which was 56, and that gets you a ratio of 4. So it's telling you that it's the 4th multiple of the empirical. And since the empirical was C3H4O, the 4th multiple of C3H4O is your C12H16O4, which is what we got there. So this problem is exactly like the previous one, but we add in one last little step at the end where we have some sort of other information where they tell you something beyond the empirical formula.